Okay, a very good morning to all. Okay, this is the topic in metal cutting and forming. Okay, this is nothing but the topic is cutting tool materials, geometry, and surface finish. It is very much important when we learn about the machine tools. Whenever you're talking about machine tools, single point cutting tool, and multi-point cutting tool, then you should know what exactly this material. Whenever you have to cut a material, whenever you, example, if you want to cut a vegetable, you take a knife. If knife is made up of a paper or a plastic, can you able to cut the vegetable? No, it's highly difficult. Similarly, when you have to remove the material, when you have to do some material machining operation, when you are doing some material removal operation, example in the lathe, drilling, whatever this thing, the drill bit or the tool which is cutting material, that should be very hard compared to the workpiece. This is true, right? Yes or no? You agree with this, right? Something like our vegetable and knife, here also the tools should be very harder material. Then only you can be able to remove the material. Otherwise, if the cutting material is very soft, soft means it is very comparatively soft, then what happens? Whenever you're doing the operation, simultaneously, even tool will also get wear out. Wear out means the it will get blunted, means the sharp edges of the single point cutting tool or multi-point cutting tool will get wear out. It get blunt, means the sharp edge will go off because of the friction between the material. So this is what we are going to deal in this module. Okay. So what is that? So let us go to the characteristics of cutting tool. What should be the characteristic? That cutting tool is subjected to high temperature, high contact stresses, rubbing along the tool chip interface along the machine surface. Consequently, the cutting tool material possesses the following characteristics. Whenever you manufacture a cutting tool, means that material should be very harder. How to make that? It should withstand high temperature, because definitely when this whenever there is a cutting process, whenever the material removing process is in progress, there will be a friction between the two material. Because of this friction, the temperature will go high, temperature will increase at the interface. So we need to reduce the temperature. How we are going to reduce the temperature? One thing is that making a material resistant to high temperature. Second thing is using the cutting fluid. Cutting fluid nothing but coolant, something like a coolant, something like a water or something. The coolants, which is industrial coolant, they're going to use it. So whenever you put the coolant at this, what happen? It will cool down the material. It will take off the heat. That is what the meaning here. Okay. So hot hardness is the ability of the material to retain its hardness at high temperature. What is that? It is resistance. It's the ability of the material to withstand high temperature. There are some material, there are some alloys, there are some alloys. I'm talking about alloys now. I'm not talking about metal. Remember, I'm talking about alloys. Alloys is nothing but it's a combination of two or three metals, right? You all already know this about this. When I manufacture using this thing, so I will choose a material in I will design or develop a material in such a way that this material will withstand high temperature. This alloy will withstand high temperature. You all know that whenever you have seen the rocket, right? Whenever rocket goes up, there is a huge flame at the bottom side. At the bottom side, at that the structure at the bottom is completely made up of a ceramic object, ceramic material. Why did they use ceramic material? Because ceramic is the high resistance material, high temperature resistance material. This will withstand very high temperature. If I use the steel, aluminum, or some other material there near that exit, what happens at the exhaust part? What happens because of this high flame, high temperature? Whole thing will get melt down. So in order to avoid that, they will use what? High resistance, high temperature resistance material. Similarly, in the cutting tool also, whenever you're doing, the material should withstand high temperature. Next is toughness and impact strength. Should be able to take the load. It should observe the load. Okay, it should take the impact load, sudden load, failure. It should have the material. It should have the capacity to observe the energy. Whenever there is a vibrations in the material should withstand that. It should not get break down into two pieces. So whenever you're cutting tool, whenever you design developing a cutting tool, whenever you're using choosing a metal, cutting material, that material should be very hard. And second point is it should be very tough and you should have enough good impact strength. Impact nothing but sudden load. Next, very important property is wear resistance. Wear resistance means what? Whenever there is a cutting process is going on, the tool material will not should the sharp edges of the tool material should not dent blunted. You should retain its original position. If you keep on cutting the vegetable from the knife, okay, after 6 months or 8 months, what happens? Your knife gets blunted, right? Then again, you take that knife to the nearest market, a grinding people, and you once again you sharpen that things, right? Though these things should not happen in the cutting tool because whenever there's a production process goes on, this whenever there are changes in the cutting tool, what happens? We cannot able to achieve the desired desired geometry. The product dimension will go change. So what that's the meaning of this. So whenever you choosing the material cutting tool material, you should have a wear resistance property. Next property is thermal shock resistance. Thermal shock resistance, whenever there's a sudden change in the temperature, sometimes what happens, temperature rapidly increases, and what happens, this material should withstand that shock. Thermal shock means sudden change, variation in the temperature. The material should have capability to withstand its original dimension. Means something like I have some example. I'll take it Tejas. I'll give I'll I'll prepare one what do you call material, and I will put it something like a cloth material, something like a space suit, something kind of thing. Okay, and I'll ask him to stand near the high temperature around 300, 350 degrees Celsius. He should not get any damage. Okay, similarly I'll take him to stand near the Antarctica or Arctic region. Even he should not get because of minus 80, 90 degrees Celsius. Even he should not get feel chill. So this is what means you should withstand the variation of the temperature. That's the meaning of that things. Okay, chemical stability. Chemical stability means whenever we are cutting the material, we use some coolants. We use some chemical coolants. What happens? This should not get chemically affected because of this chemical. There should not be any acidic kind of thing. Okay, it should not react. That's the meaning of this thing. Chemical stability and inertness means with respect to the material being machined to avoid the minimize any adverse reaction. Addition, the tool chip diffusion that would contribute to the weld tool means whenever you are cutting the cutting material should not get stick to the workpiece. That's the meaning of this. So chemically stability and inertness should have there. Next, what then what sir? Then you may ask, sir, if you tell all this property, then which are the materials normally use it in our markets? Whenever in the lathe shop, machine shop, all these things. Yes, there are some materials. Which are that materials? High speed steel, carbide steel, carbon coated steel, car cubic boron nitride, diamond, aluminum oxide. These are all the materials they are going to use it for tool manufacturing. What is the tool manufacturing? Why they use this material? You understood why? Because this material have that properties. Which property? High resistance property, wear property, thermal shock property, resistance property. Okay, all this impact resistance property, all this property this material have. That's the reason why people or scientists or material inventors they will use this high speed steel, carbon steel, carbide steel, diamond steel, all these things. You know that diamond is the very hardest material. Okay, it can able to cut another diamond when if it is in the, that's the reason they will use it in the jewelry shops, all this purpose. Hope you all know about these things. Okay, still let us see what is that carbon steel. Carbon steel is the oldest tool material because whenever you use more carbon in the steel, you know about the difference between steel. Okay, so steel is nothing but it's alloy. It's nothing but it's a iron plus little bit of carbon. If you keep on adding the carbon percentage, what happens? It becomes a cast iron. It becomes a cast iron. So as the more percentage of carbon is added to the iron, it becomes a steel. When more percentage of carbon is there, then it becomes very harder material. This is a very hard material. Low alloy, medium alloy steels were developed for a later similar application but with longer tool life. If you want to make a life of the tool should be longer, then they will use carbon steel. Okay, where they will use their use is limited for low speed cutting operation, particularly in woodworking. Whenever you have to take the remove the wood processing, means we have to cut the material, wood material, then they will go for use the carbon steel. You know, to the go to the carpenter, you see a number of tools with him. Okay, all these tools are made up of carbon steels. Okay, not only carpenter, they will use some carbon steel for some other purpose. But what is that? Low speed cutting operation. Whenever you have to cut for a small operation, they will use, whenever the operation is in low speed, they will use this carbon steel. Next, high speed steel. What is that high speed steel or HSS? They will ask you in the question examination, write a short notes on high speed steel, that is HSS, carbon steel. Okay, you need to write this. High speed steel tools are so named because they were developed to the machine at higher speeds than carbon steels. High speed steel is a highly alloyed tool steel capable of maintaining its hardness at elevated temperature. Underline this word. Okay, high speed steel nothing but it's highly alloyed. Alloyed means alloy. It's a alloy of a steel and carbon. Sorry, it's a alloy of a steel and iron. But percentage of carbon is very high. What it will do? It will withstand very high temperature. So better than high carbon and low alloy steel. It's good hot hardness permit tools made up of HSS because one of the property is that it has a very good hardness property. It can withstand. It is a very hardest material. So in this also there are two varieties of the tungsten type graded American Iron Steel Institute, there and molybdenum type. All these are the different varieties. Means people, this tool manufacturer will identify. They will put the name on they will on the tool, which type of material, which what is the condition, what is the dimension, all these things. So based on the what are the standards they are going to manufacture. Okay. Hope you are all there with me, right? Yes or no? Tejas, Chandan,
Yes, sir.
Joy, Joy, are you there?
Yes, sir.
Sir,
Okay. Yes. Okay. Next, molybdenum high-speed steel. What is that? Molybdenum high-speed steel. It contains a combination of tungsten and molybdenum plus some additional alloy element as it is in T grades. Means as specified in the T grades, means as specified in the American standards. Okay, they will use tungsten material. They will use tungsten material. That is a real thing, but it's a T grade molybdenum. Okay, when all this mixture put in together, it becomes a very high hardest material. Sometimes this materials also be used in the tool manufacturing. So it's various percentage, something like 18%, 4% chromium, vanadium, all these things they will going to use it, and they'll tungsten means W, that is a chemical formula. Okay, cobalt, CO, all these material put it together. That is I told in the beginning, it's a alloy. It's not a single metal. It's alloys. Means suppose I'll take in an example. I'll take this third semester as a group. Tejas is a very what do you call? Is a very his handwriting is good, so I'll choose him. Next, I'll make one person, one more Joy. His memory is good. Okay, I'll select him. Next, one more person, something Chandan, something or some Rishikesh or some other students. Okay, I will identify each plus point in the students. And each plus point is a Gagan, Gautam, something like this. Mandesh. I will identify one or two properties. Maybe one person has good handwriting, one has got good memory, one can write very fastly, one can repeatedly tell, continuously can dictate the things. So I'll make this group and put it together. I'll tell this group to, okay, you people have to do one project. I'll give some project, mini project. Can you ever? Then these people will work like a very in a very good manner, and they will do some wonders. That is how they will select the each and every material, which are properties in that material. They will put all this property put in together. It becomes a very cemented carbide also on the material. They are going to use it in the tool cutting. It's a tungsten carbide. They use powder metallurgy technique. I think you are not Yeah, I don't know whether you are not aware of this powder metal technique, but I'll tell you, you understood about the casting, you understood about the machining process, you understood about the welding process, all these things. There is one more material, advanced material process, that is material technique, material process. This is called powder metallurgy. What is that powder metallurgy, sir? First, they will not melt the material here, like just like a casting. Okay, what they will do? They will not form the forging. They will not do any forging. What they will do? They will take the fine powders of materials or alloys. They will put it in a small die and they will press it with a high temperature. With high temperature, they will press it and remove it. It will take the shape. It will take the shape. This is called powder metal. I'm just briefing out. I'm just telling in a very brief manner. But in detail, there are two, three, four techniques in this. Okay, two, three, four procedures are there here. So they will take the powder and they will put it in a die and they will press it. They will compress it with a high pressure and they will remove it so that they will get whatever the shape size they wanted. Okay, this is called powder metal. This is how they manufacture cemented carbide tools using powder metallurgy techniques. So next, ceramics. I told, given a very good example of a rocket. So ceramic is one of the finest material. Okay, where it can withstand very high temperature. Very high temperature. That's the reason why in the space, aircraft, all these things, wherever there is high resistance, high temperature comes into picture. Okay, as a shielding material, they will use ceramic material. Okay, this is one of the ceramic is also one of the toughest and hardest material where they're going to use it in the mix with other alloys, maybe aluminum oxide, uh, aluminum oxide, zincorium oxide, all these things. They'll mix it, they'll prepare the material. So next, cubic carbon nitride. Next to diamond, cubic boron nitride is the hardest material known. First hardest material is diamond. Second hardest material is cubic boron nitride. Okay. What is the cubic boron? Cubic boron nitride is a material where it has got some cubic boron nitride plus tungsten material with a little bit of tungsten is added to this. They're going to use it where? For cutting the material like steel, nickel alloys. Okay. These materials are very expensive. Okay. These are very expensive material. Next, diamond. You know that diamond is the hardest material known by some measure of hardness. Diamond is 3 to 4 times hard as a tungsten carbide. Tungsten carbide, first of all, tungsten carbide material is a very costly and hardest material. It is 3 to 4 times heavier. Diamond is a 3 to 4 times harder than tungsten carbide. You can imagine what kind of hardness it has got. Okay. So this is the property. So next they will use cutting tool, multi-point cutting, nose radius. Okay. These are this if this figure is very much important for your examination point of view. I don't know whether you by heart it or practice it, but this is one of the important question. Okay. You need to practice the things. Okay. Next, I will share this PPT, I mean PDF to you, is a material to you. You can learn all this. This is a multi-point cutting tool. As I told, this is a drill bit. See, here there are number of sharp edges here. One, two, three, something. Around the circumference there are sharp edges. So these are all the multi-point cutting tool. Axa blade or a drill bit tool. All these things are multi-point cutting tool. So okay. Next, uh, so this is another tool, the milling tool. See, can you see that the number of sharp edges are more here? This is the milling tool. Compared to when it comes to, and I wanted to discuss a small topic that is on cutting fluid because this is very much important. So tool, whenever you do some operation on the material, so there are many materials. So it is very much important in whenever you do using a tool, it is also using the cutting fluid is very much important. What is that cutting fluid? Cutting fluid. Cutting fluid is a liquid or gas that is applied directly to the machining operation to improve the cutting performance. Sir, how the cutting fluid will improve the performance, sir? It is just a liquid. It is something externally. We are just putting something like a water over the material. How it improves? You may ask the question. When there are two problems in this, whenever you're cutting the material with the workpiece, what happens? Whenever you keep on cutting the material, what happens? There is a friction. Because of this friction, heat generation, it is generated. There is a tool tip friction. Remove this heat. What they will do? They will use this cutting fluid. Sometimes cutting fluid may be something you can see that maybe in the blue color, green color. If you take automobile, a car or something like this, they will use coolant inside the engine, the radiator. What is that coolant? It will keep on circulating. What is the purpose of the coolant? So this is the function of the cutting fluid. There are four categories of cutting fluids. One is cutting oils, emulsified oils, semi-chemical fluids, and chemical fluids. There are four types of fluid. Cutting fluid. They use oil derived from petroleum, animal, like a grease. You know that your tutti oil, for the bike and all gearbox oil and brake oil, all these things are petroleum based. I mean, they are the byproducts of petrol, crude oil. Okay, and animal oil. What are animal oil? Animal oil. Some oil will be extracted from the animals also, from the sea animals. Also, marine animal means the animals, the living beings which are present inside the water, they'll extract the oil from them and vegetable something like this. Okay, there are many mineral oil and sometimes when you deep mineral oil. So all the principal types because of their abundance and generally desirable lubricating characteristics. This can lubricating. What is the lubricating? Lubricating is done only to reduce the friction. So where and all you use sometimes you require a friction. Sometimes this friction should not be there. Where you should require the friction, you have to reduce the friction in the engine. You have to reduce the friction in the engine, whereas you should increase the friction in the tire between the tire and road. Then only your tire will move. If there is no friction between a slipper and a ground on the ground, this is the right. This is the right. Some they should reduce the friction. The other cycle will not move. The bicycle will come down. That's the meaning of this. So there is a water means it is an oil which is mixed with the water. The fluid okay. Water is 30% and 1% of the oil. When you oil, you'll add little bit of chemical additive like sulfur, chlorine, phosphorus to this. Okay, they will use this emulsified oils in some cutting process, material cutting process. Okay, this is called emulsified. Emulsified means the diluted oil with the water. Okay, next chemical fluid. These are the chemicals in the water solution rather than oil, sulfur, chlorine, phosphorus, all these things, and they will use it for as a cutting fluid. This is one of the cutting fluid. Next, application, functions, purpose of cutting fluid. The primary function of the cutting fluid is to temperature control. Of course, I have repeatedly telling these things to cooling the lubrication. Okay, and improve the quality of the workpiece continuously. Because if you won't use the workpiece, sometimes what happens the surface finish, whatever the machining operations do, the surface finish will not be to the desired level. So that in order to get better surface finish, we'll use this coolant. To cool the tool, to cool the workpiece, to lubricate and reduce the friction, to improve the surface finish, to protect the finished surface from the corrosion. Sometimes we need to, mm, sometimes we all know that we will do some paintings to the iron bars whenever there is a gate and windows of your house. In the rainy season, especially rainy season, the winter season, before that we'll start painting. What is that? Because whenever it reacts with moisture, it starts, what do you call it? If rusting will take place, rust will take place, means the whole thing will get, the structure will get damaged. And so to avoid that corrosion, what they will do? We'll do that. So to cause a chip breakup into small parts, to wash away the chips away from the tool. Sometimes what happens, whenever you keep on applying the coolant, the small powder, whenever the chips, it will wash away. It will take away from the along with the water, means coolant. This is one of the advantages. So methods of application, manual application means sometimes you will take the grease, sometimes you will take the oil and you will drop it 2 to 3 drops, you use it and you perform the work. Sometimes what happens, flood application, sometimes whole tool and workpiece, okay. So there is a nozzle system, there is a pipe kind of structure, there's a continuously the pipe will be, pipe will be, from the pipe the water, the fluid, cutting fluid will be coming out. It is flooding. Flood means what? It's completely surrounded. So once you, just like how you use the deodorant and the sprayers, something like that, there is a mist application. If you spray it over the tool, sometime till some little, something like a mist, it will form over the surface. So this is one of the applications. So these are some of the applications. And last bit, I'm just talking about these parameters affecting the surface finish. What are the parameters? When you want to achieve a good surface finish material from the cutting material, when you have to remove, whenever you do any material removal application, if you want good surface finish, then speed is one of the very important criteria. If you work with rate mechanical surface will be okay. If the tool very slow finish will get very good surface finish. Okay, full for the material, what happens? There will be some zigzag kind of thing. There will be some rough surface. That's the meaning of thing. Feed, as I told, feed should be very slow or low. Depth of the cut, lower the depth of the cut always preferred in order to good. Means whenever you penetrate the tool inside the workpiece, with the depth of the cut is very less, then you will get a good surface finish. Means we need to do very slowly. You should increase the depth. Then only good surface finish. If you go suddenly higher depth, what happens? The material surface means become very rough. Cutting tool geometry. The tool should have maintained the desired shape angle. As I told, as I shown that three views of a cutting tool, the nose radius should be very properly, should be there, should be maintained. If this a little bit blend, what happens? The whole surface, the cutting, for this I can able to answer. Chandan, Gagan.
Sir, sir,
And then
Sir, yes.
Mahendra.
no
Any
sir,
doubt?
no sir.
No,
No,
sir.
sir. ಸರ್ ನಾನು ಲೇಟಾಗಿ ಜಾಯ್ನ್ ಆಗಿದೆ ಸರ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಏನಾಯ್ತು ಅಂತ ರಿಪೀಟ್ ಮಾಡ್ತೀರಾ ಸರ್
ಮಾಡ್ತೀನಿ. Next. Shashank, Siddharth, Tejas.
No doubt, sir.
No sir.
No doubts. Right. So, okay. I'll just take 2 minutes of time because he asked some doubts. What I completed in the first part is I'm talking about materials, right? Cutting tool materials. I'm talking which are the materials they're going to use it for cutting what do you call material removal process. So I told these are the materials. So I just started here. Cutting tool materials, geometry and surface finish. See, the cutting tool materials is a particular application. Most factor means what are the materials we're going to use it. Whenever you choose a cutting as a cutting tool material, this material should have some property. What is the property? It should be very high. When I told very good example, if you want to cut a vegetable, the knife should be very harder. Knife should be very harder, sharper, all these things. Then only I can cut the vegetable. If knife is blunt or it is wear out, okay, I cannot able to cut the vegetable. That's a very simple, right? Keep that in mind. Similarly, if you want to cut a material, the cutting tool should be very harder. It should be very tough and it should be able to withstand high load and impact load. It should have a wear resistance. The sharpness, the sharp edges of the tool should not get blunted or wear out. It should take a more thermal shock. It should be able to withstand high temperature. Chemically stable. Whenever you add some coolant, something grease or something like that, whenever you are cutting, something like you might have seen that whenever you cut a vegetable, the sharp edges of the knife should not get, the color of the knife should not get changed. That's the meaning of chemical stability. Means the material should be chemically stable. So then what are the materials they will use it for cutting tool metal? They will use carbon steels, high speed steels. Okay. And one more thing is tungsten type HSS, molybdenum high speed steel, cemented carbide, ceramics. Okay. And carbon boron nitride. Sorry, carbon is not cubic boron nitride and diamonds. And so, what is this material? Whenever you take these materials or this, except diamond, remaining all materials is alloy. It's a mixture of alloy means two or three material put in together, they'll manufacture the cutting tool because this material should be very harder, very tougher, chemically stable, it should withstand high temperature. If you want to get all this property, then I should use the alloys. So which are the alloys? The material should be very as I told, I give an example in a classroom. Some student has got very good memory, some has good handwriting, some has come people can able to write very neatly, very fastly. So I'll make a group. Then these people will perform very better in a better way. That's the reason why I use molybdenum, okay, tungsten, carbide, carbon steel, all these things, boronated. Whenever you use this material, this becomes very hardest material. Then I can able to utilize for a cutting tool. So what is a cutting tool? It may be there are two types of cutting tool. One is single point, other is the multi point, which I already taught in the last class. Single point multi point is something like a the sharp edges will be there where at one point, one edge, there is a cutting edge, and the material is going to remove. Multi-point cutting, nothing but it's a material or a tool where it has got multiple sharp edges, something like a drill bit or milling cutter, all these things. So this is what I'm teaching at the first phase. So last class, hope you attended, Mahendra, right?
Yes, sir.
Okay, I'll share this PDF to your mail ID. Okay, please listen. Please, if you have any doubts, get back to me. Okay, right? So cutting fluid is very important. Characteristics of cutting fluid is very important. And what are the materials used for cutting to material? That material is list is important. Okay, list plus a little bit of description is very important. And cutting tool geometry of single point cutting tool is very, very, very important. Okay, if you read these three topics in the first module, you will get at least 2 questions from this. Okay, any other doubts you can raise. Any doubts you can raise. Any doubts from your side? Okay, then I'll share the PDF. Please read that. Okay, thanks for attending. Thank you very much.
Thank you, sir.
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you. Thank you.